Today we're going to be solving equations by multiplication and division. Our objectives are going to be to solve linear inequalities by using multiplication and division. We're still only going to go one step today. Okay, there's one extra rule. When multiplying or dividing by a negative, you must flip the inequality symbol. Okay, so that greater than or less than symbol, it's got to be flipped going the opposite direction if you multiply or divide by a negative. So this first example here, we have negative 3x is greater than 27. Okay, the negative 3 is attached to the x by multiplication, so to unattach it, we're going to divide. So we're going to divide both sides by negative 3. And I'm going to go ahead and put the answer here. Where x, since we divided by a negative, it's going to be less than, see how we flipped this, and it's going to be negative 9. This next equation, we have x divided by negative 4, so to undivide that negative 4, we're going to multiply by negative 4. So I'm going to multiply this side by negative 4, the other side by negative 4. The negative 4 on the top here and the bottom cancel. So our answer is x, where x, okay, once we multiply both sides by negative, this flips again. So it was less than or equal to, now it's going to be greater than or equal to negative 12. And we won't graph those ones. So any fraction, you're going to multiply by the reciprocal. So here's one with a fraction. We have negative 3/5 d is greater than or equal to 6. So the fraction here with the variable is negative 3/5. It's multiplied by the variable. So to unmultiply, you divide, right? So we would divide negative 3/5. The problem is, what do we do when we divide fractions? We multiply by the reciprocal. Okay, so this should make sense to us. If we flip 3/5 to 5/3, that negative is still going to be there. We're still going to have a negative. That negative is not going to go anywhere. So when we multiply on both sides, we're going to multiply by negative 5/3. On the left side here, the negatives cancel, the 3's cancel, the 5's cancel. We're left with d. Okay. When we multiply both sides by the negative 5/3, this inequality flips again. It's going to go to less than or equal to. Now, a lot of you still need to put the 6/1. That's fine. Okay. This can be cross-canceled. Some of you are going to say 6 times negative 5 is negative 30. 1 times 3 is 3. And then you're going to go ahead and reduce to negative 10. That's fine. You can also cross-cancel and say that 3 goes into 3 once. 3 goes into 6 twice. So we're going to end up with 2 times negative 5, which is also negative 10. So it doesn't matter which way you do your fractions. I think cross-canceling is much easier, especially when we get into bigger numbers. Let's go ahead and do a couple more examples. Pause if you need to write those last examples down. Okay, we have negative 1/3 x is greater than 10. We got to find the reciprocal of negative 1/3. That'd be negative 3/1, which we'd actually just simplify to negative 3. So I'm going to go ahead and I'm going to multiply both sides by negative 3. Okay, negatives cancel, 3's cancel. We end up with 1x or just x. We multiplied both sides by a negative 3, so since we multiplied both sides by a negative, our sign flips. And 10 times negative 3 is negative 30. So these ones we're going to go ahead and graph. So you can see your answer is x, where x is less than negative 30. Or you can see your answer on a number line graphed. Again, our answer was negative 30, so we're going to have to put negative 30. The one right before it's negative 31. Again, our numbers are backwards, to the left of 0 on the number line. And here's negative 29. There's no equal sign, okay, so it's going to be an open circle at negative 30. And here, x is less than negative 30. Again, we should know x is less than because the inequality sign, if you look at it as a mouth, is not eating the x. So we're going to go backwards to show that it's less. All right, this next example here, we're going to divide by 12. So we divide by 12 on this side, divide by 12 on the other side. These cancel, we get s. Okay, not every time we multiply or divide do we switch the inequality. Here, we divided by a positive 12. We wouldn't flip it. We'd leave it. Okay, and then we'd bring 60 divided by 12 is 5. Now that's the answer. But let's say the 60 was negative. If that 60 is negative, we still don't flip the inequality symbol because we didn't divide by a negative. We divided by a positive 12. So if our 60 was negative, our 5 would also be negative, but the inequality would still not flip. So if I was going to write my answer, assuming that that 60 was negative, it would be s, where s is greater than or equal to negative 5. Okay, And if I graphed this, negative 5 would go in the middle, negative 6, negative 4. There's an equal to sign on this one. S is greater than or equal to. So when I plot my point at 5, I'm going to color it in. Now, since S is greater than or equal to, and since the inequality is eating the S, it's bigger, and we're going to go to the right. A couple more examples here. Negative 8Q is less than 136. I'm going to go through, I'm going to divide by negative 8. Since I'm dividing both sides by negative, I flip the inequality, and Q is going to be greater than, okay, 8 goes into 13 only once, and then we get a remainder of 5, and 8 goes into 56, 17. So Q would be greater than negative 17. Again, two different ways you can see your answers on Canvas. You need to get used to seeing them both ways. Okay, and then as a graph. So as a graph, I'm just going to go negative 18, negative 17, negative 16, open dot because it's not equal to, and since Q is greater, it's eating the variable is bigger, it goes to the right. And this one here, very similar, negative with the variable and a positive without. We'd go ahead and divide through by negative 4. Z, the inequality would flip, so Z would be less than negative 16. Okay, so Z, where Z is less than negative 16, or we can graph it. We have negative 17, negative 16, negative 15, open circle, there's no equal to sign, and since Z is smaller, it goes back. All right, so we're going to go ahead and start work on iPads.